Yes, hello everyone and welcome to the live session. Today we are going to start a new subtopic of reaction mechanism. We have already covered a lot of topics of reaction mechanism last week. I decided to start this topic because uh, when we look at any organic book, we do not find any chapter which is devoted particularly to a reaction mechanism. For example, when you open Claydon, what you find is everything is scattered little bit, not at one place. So this lecture series is going to help you a lot in order to understand the reaction mechanism very well and how you need to study this topic. In the last week, we completed some mechanisms and we have gone through the basics of substitution reaction. We have also seen how the molecular orbital theory governs the substitution reaction. Now, in today's lecture, which will be in continuation with the last week lecture, I will be starting a new mechanism today, and that is going to be SNI mechanism. Our target is to start SNI mechanism. Okay, so you can say this is lecture number 6 in continuation, or you can say this is lecture number 1 for this week. So first of all, very good morning to each one of you, and welcome to the live session. Good morning, Pragriti. Good morning, Camp Pacific. Vishal, good morning. Good morning, Himadri sir. Good morning, Spread Peace. Praful, good morning. Good morning, Pooja. So, welcome to the live. And one more thing, uh, here they have mentioned practice series. This practice question series we will be doing from Wednesday, not from today. First of all, we need to cover the concepts. Then only we'll be able to solve the questions. No, so it's very important to first of all go through the concepts. So, good morning, Shubham. Good morning to everyone. So I want to start straightforward, and of course, you people know that this complete lecture series is in English only. I am trying to explain each and every topic in English only so that the students from South India or any student who face problem in Hindi language as a barrier, so they should not suffer. That's why this complete lecture series will be in English only. हम्म, कैसे हैं आप? आई एम वेरी वेल शुभम, हम अच्छे हैं, आप बताएं आप कैसे हैं? चलिए, लेट्स स्टार्ट. So let's take a recap what we have studied in previous lectures, or I can say on the lectures which happened on Saturday. We covered what is SN2 reaction, some basic things about SN2 reaction. The important thing was in the transition state, what's the hybridization of a transition state and how and what is the steric number. This is how the potential energy diagram for SN2 looks like. Moving ahead, we have a role of solvent, how solvent can play an important role in deciding the nucleophiles also, and in SN2 reaction why we use polar aprotic solvent. I have answered all these questions and we have compared this with SN1 reaction too. Moving ahead, yes, we have talked about the solvent. Then in SN2 reaction, we often form a product with inversion. That is, if you started with a S configuration, you ends with a R configuration. And if you start with a R configuration, you ends with a S configuration. This is what we have talked about. Good morning, Khushi. Good morning, Kishore Kumari. Badhiya sir. Okay, Shubham. Then we saw ring size and how ring size can affect the rate of SN2 reaction, and this question was also asked in UPSC geoscientist prelims examination which just happened on the last Sunday, I think. So you must have, if you have given the paper, you must have gone through this question also, and this contains a very easy concept, but a little small trick was that 5-membered ring exists in an envelope form, because of which its rate of SN2 reaction becomes fastest as compared to 6-membered ring also. Good morning, Amrapali. Good morning, Suganti. Good morning, Koila Mundi. Okay. I'm sorry if I pronounce your name wrong. It is not intentional. Good morning, Mosmi. Moving ahead, we have compared that how an SN1 and SN2 reactions can be compared on the basis of 10 points. Then we started with some substrates which give best SN2 reaction and some substrates which give best SN1 reaction, and the substrates where SN1 and SN2 are not possible, which we have talked about. Now in today's lecture we are going to talk about SNI mechanism. This, can you tell me in the comment section, in whenever I talk about SNI, what does this I stands here? What does this I stands for? Of course, SN means we are talking about nucleophilic substitution, but what does this I means? Nucleophilic substitution. But which type of nucleophilic substitution? Very good. It is called as intramolecular nucleophilic substitution. Intramolecular nucleophilic substitution. You can call this as the internal also, Akansha. The meaning which this I contains will be conveyed by internal also, but we prefer uh, intramolecular. Intramolecular nucleophilic substitution reaction. See, what happens in this reaction is, in this mechanism is, let's suppose you have an alcohol as a starting material, then always you get SOCl2 as in order to make this OH a good living group. You may get ether as a solvent also, or most frequently we use 1,4-dioxanes as a solvent molecule, and of course these are ethers. Once you form the product, you get R group, and this OH is replaced by the Cl, and this switch acting as a nucleophile. The main important point in this, in any SNI reaction, is if you start with, let's suppose, S configuration, then you end with S configuration. If you start with, let's suppose, R configuration, then you end with R configuration. It means in an SNI reaction, you always form a product which is of retention. Always we form a product of retention. See, SNI reaction can be carried out in three ways. Either the examiner, see, if I talk about SNI mechanism, examiner is going to give you this in three ways. First of all, whether the examiner is going to use ether as a solvent, and most frequently used ether as a solvent is 1,4-dioxane. This he will use as a solvent. Or the second possibility is this SNI reaction is carried out in the presence of pyridine. Okay, then also we form a little different product. And the third possibility is nothing has been used by the examiner, only SOCl2 and nothing else. Of course SOCl2 will be present here also, and your SOCl2 will be present here also. These are the three cases, three scenarios by which your SNI mechanism can be asked by you, asked by the examiner to you in the exam. SOCl2. So what's the difference between P product, between Q product, and between R product? Can anyone tell me which are the cases where I am going to form a retention product, and which are the cases where I am going to form a inversion product? Are you aware of this or not? Dioxane, yes, very good. Camp Pacific, Akansha, yes, the retention products are going to be formed. 2 times SN2 happening. Yes, Camp Pacific, you are going right. Manisha, good morning. Rahul is saying, sir, Q will form an inversion product. Q will form inversion. Only first may retention. Okay. See, if I give you the final result, what we observe is, if we have 1,4-dioxanes as a starting material or as a solvent with SOCl2, we observe that the product formed is of retention. It means if you started from R configuration, you ends up with an R configuration. If you start from S configuration, you end up to be in S configuration. And similarly, if you use pyridine, then now the situation has changed, and in this case you are going to form an inversion product. If you don't know the mechanism also, it will work for a while, but if you don't know the final result, this is not going to work. You need to know which type of solvent or which type of substrate is going to give you what type of product in an SNI mechanism. And if examiner has simply mentioned SOCl2, then also you need to remember only retention products are formed. Only retention products are formed. Simple SOCl2, a retention. Pyridine inversion, 1,4-dioxane, then again a retention products are going to be formed. Now let's have a little look on how the mechanism of the reaction works here. If you allow me, I will be moving on the mechanism part. Tell me fast. So these are the three possible scenarios where an SNI reaction can be asked. First of all, we will look what if we have a simple SOCl2, then how the mechanism works. Let's have a look. See what is happening first of all. Let's suppose I have a chiral center present here, and at the starting material we have a alcohol as a starting material. Now we have put thionyl chloride as an group which will make OH a good living group. So first of all, the oxygen is going to attack at the sulfur center, and from here, since this center is very electrophilic, we are going to form a intermediate which will look like this. Now, once this O minus comes down, this Cl is removed, and in this process, here you get a Cl minus which is eliminated. Now, in the second scenario, what is happening? Now, the Cl which is present into the SOCl2 is going to attack at one of the carbon center, and the group is going to be eliminated from here. Of course, you are going to eliminate a SOCl2 gas here, but why an retention product is formed? Because the Cl is attached on the same side as the oxygen was attached in the starting material. Why we call this as intramolecular? Because the Cl which is attached into the living group, focus here, the Cl which is attached into the living group attacks on the carbon center, and it is acting as a nucleophile, and the nucleophile is present in the molecule only. That's why this is called as intramolecular nucleophilic substitution reaction. The nucleophile was the part of your molecule, or we can say of your substrate only. Then how does it, then why it is happening that we got a retention product? Because the attacks takes place from the front side or from the same side, at the side where you have your living group attached. That's why we ends up into a retention product. Did you get this concept, or did you get this mechanism or not? Tell me fast. Did you get the mechanism of the reaction? So this was the third scenario when we only have SOCl2 as a substrate, or we can say as a reagent. And of course, the final product is going to be of retention. So I will be writing here as we got a product which is of retention. Okay. So you may note this down also. See, if you forgot the mechanism, it will work, but you need to remember the final result. How the final result is working, that is very important. Okay. Good morning, Deeksha. Good morning, Preeti. Let's move ahead and see what we have more. If I talk about the previous mechanisms, it means what happens if we have a 1,4-dioxane or a ether, then how the mechanism works. So again, I have a simple figure which will be explaining all the three. Let's see how they are explaining. If there are any mistake, I will correct them also. See, first of all, the oxygen is attacking on the SOCl2. Of course, this is going to happen because OH is not a good living group. First of all, we will be converting this OH into a good living group. One of the Cl is eliminated, and we get a intermediate which looks like this. We have an oxygen center which has been converted into a good living group. This is what we obtain in all the three mechanisms as they are saying. Okay. Now, If we use dioxane as a starting material, so what is going to happen is, now this dioxane lone pair attacks at the carbon center present here in our starting material, and this group is eliminated from here. It means this, if this is attacking at this center, the mechanism it is following is called as SN2 mechanism. Now the Cl minus which is eliminated, let me explain you on a different slide because they are confusing little bit. See what is happening. Let's suppose I have a chiral center, okay, an R group present here, and R group, let we call this R1 group, R2 group, and an R3 group with an OH group present here. We have SOCl2, so we have written this as like this. What is happening? Oxygen lone pairs attacked at the sulfur center. This goes up, this goes down, and the Cl is eliminated. In the next step, we have oxygen and we have sulfur double bond OCl. We have an R1 group, below the plane we have an R2 group, and at this center we have an R3 group. Now what happens is, your solvent molecule comes and participates into the reaction. Your 1,4-dioxane attacks at this center, eliminates the group. You may see a gaseous molecule coming out, that is SO2. But since this mechanism is a SN2 mechanism, because your uh, nucleophile is attacking from the back side, so I will call this mechanism as SN2 mechanism, and the product will be formed of inversion. It means your solvent molecule will be intact here or attached here, and you will be having R1 group, you will be having R2 group, and you will be having the R3 group. Since one time SN2 has taken place, the inversion product has been formed. You may also realize that you have two molecules out here. One was your SO2 gas and one was your Cl minus. This Cl minus comes back and is going to attack once more into the sigma star orbital and will eliminate the solvent molecule. And again, this mechanism it is following is SN2 mechanism. Here also the mechanism was SN2, and again the mechanism is SL2. So we get a Cl at this center, we get a R1 group here, our R2 group is here, and an R3 group is here. Since two-time SN2 mechanism has taken place, at the final result we form the retention product where Cl is attached on the same center as that of oxygen. And let's suppose we started with an R configuration, then by an SN2 of solvent molecule it get converted into S configuration, and then because of the SN2 of Cl minus it again got converted into R configuration. If you must have started from S, it must have converted to R and again back to S. That's why we call that, yes, we have formed a retention product. Did you get the concept or not? A retention product. Is this digestible to you? How the solvent molecule is helping here in order to make this mechanism of a retention. Inversion of inversion in the case of dioxane, overall retention. Yes, very good, Akansha. In the case of dioxane, what is happening? There are two times SN2 reactions taking place. That's why in the final result, we are forming a retention product. If dioxane was not present, then also retention product would have been formed, but the attack was taking place from the same side as that the nucleophile was attached. Good morning, Ankita. Got it, sir. Very clear, very clear. Excellent. So you need to copy this. Make sure these things are in your notes so that once you revise these things, these are stored in your permanent memory. So we have looked through two mechanisms. One was our simple when we have SOCl2. Now, what happens if we have pyridine as a solvent? We need to have a look through that also. See, they have explained in a little different manner. We can use this mechanism also. What they are saying is, once you have formed this oxygen, a good living group, your pyridine center is attacking on the sulfur center and is attached here. So of course nitrogen is going to have a positive charge also, and the Cl minus which is eliminated is going to attack. The Cl minus is going to attack at this center and the group will be eliminated. And in the case of pyridine, only a single SN2 reaction is taking place. only one time SN2 is taking place. So the final result is of inversion. So you may write this mechanism also. Please write it separately, all three, so that you do not get confused. Okay. So what they are trying to say is, when the Cl minus attacks at the sigma star orbital of the leaving group, only single time SN2 is taking place. So you ends up into an inversion product. So we have discussed all the three scenarios and mechanism for all these three scenarios. Please write it down fast so that we can move ahead. Let's see some questions also, how some questions can be asked on the SNI mechanism. Good morning, M Chemistry. Good morning, Shopping Era. Yes, let's move ahead and see what we have more. Did you get these three mechanisms so that we can start with, we have to start NGP also today, but before that we will try to do some questions on SNI also. Should we move ahead? Let's suppose we have a question in a Fisher form. Okay. Examiner has given us a Fisher form molecule where we have CS3 attached here and C2H5 attached here. We have a OH at this center and H at this center. Let's suppose we have some group attached here. What we can attach is, let's suppose we have a fluorine here and we have a deuterium at this center. Now, examiner has written we have SOCl2 in the presence of pyridine, or let's take 1 comma 4 dioxane. Can you draw the product for me? Or I am giving you some options also, so that you are able to solve some MSQ questions also. Let's suppose I'm making this question as a multiple select question. Okay, I'm giving you few options. You need to choose one. Choose more than one options can be correct here. Do remember this point. We have a OH here. So what I have done is, we have a Cl at this center and H at this center. C2H5, a fluorine and a deuterium. You need to check whether this option is correct or not. Then again we have some changes. We have a Cl at this center, H at this center, C2H5, we have CS3, deuterium and F. I'm again changing the question, means changing the option. Let's suppose we have Cl at this center, we have H at this center and a C2H5 at this center. We have fluorine, we have CS3 at this center and a deuterium present here. Then we have fourth option also. Let's suppose how to frame this. Okay, let's do some more changes. We have Cl present here, we have C2H5 present here and a hydrogen present here. Okay, now what we have done is, we have a fluorine present here, we have a CS3 present here and a deuterium present here. You need to tell me which options are correct. A, B, C, D, you have four options. What do you think if this question is a multiple select question? Yes, Campacific, one of the answer will be correct, where the Cl will be attached in the place of OH, but this is not that easy. You are given a multiple select question where more than one options are correct. Okay, answers are coming. B, C, D are correct. B, A and B are correct. B and D are correct. Okay. I would love if everyone would comment their answer. Let it be wrong. No problem. We are here to learn. No. Kishore is saying that A and B is correct. Option B and C also correct. B and C. Okay. Shopping era is saying sir B, C, D is correct. Let's check shopping era. See what they have done is, what I have done is, I have changed the configuration of the molecule or I have retained the configuration, just change the substituents. You need to find the RS configuration, but it will be a little bit lengthier method. You can go via some shortcut also. See, we all know that if we form the product here, what the product is going to be, we have SOCl2 and 1,4-dioxide. It means a retention product is going to be formed. Very good. We have a OH group here which will be converted into a living group, and the product is going to look like this, where we have a Cl attached in the place of OH. This should be our product. Now, is there any option which directly matched it to this? If I look at the first option, at this center we have a Cl present here, and in our answer we have our Cl present on the right hand side. It means the configuration is not matching. It's the product of inversion. So A option cannot be correct. Looking at the B option, what we see is Cl is present in the place of OH and rest all of the things are same. Then yes, this will be of course the right answer. Moving to C option, what we find is some changes has been done to this chiral center. But whether the configuration has changed or it has been retained, let's check. If at this chiral center, three atoms change their position, or we can say even number of interchanges has been done, then of course the configuration is same. So what has happened? Our C2H5 will be here. So this will be our one interchange, and then hydrogen will go here, and this will be our second interchange. Even number of interchanges, or three atom has interchanged their position, then of course the configuration has retained, and this option is also correct. Now looking at the fourth option, we find that the Cl is attached at the same center, but the center having the fluorine has been changed. Whether the configuration is changed or retained, that we need to check is. So fluorine is present here. It means I need to do one interchange here. Fluorine will go to its place, and CS3 and deuterium will be changing their position. Again, even number of interchange, we get the same molecule, and it means D will be also the correct answer. So B, C and D was the correct answer for the question. So this is how examiner confuses you in the exam. Okay. Sir, I wish all the students get 90 plus in boards exam. Best of luck. कोई बात नहीं. अंजलि जी. We also wish कि all the students, if they are giving their boards exam, they could get 90 plus marks. So this type of questions you may expect in your GATE exam, and this type of questions you may expect in your if someone is from JAM, if someone is from BSc and he or she is going to give JAM exam, there also you can expect such type of question. Hmm. Okay, moving ahead, let's start our new mechanism, or we can do one more question. Let's suppose you have a CS3 group attached here and a C2H5 here. We have a hydrogen and a deuterium here. Again, we have a hydrogen, or let's suppose I'm changing little bit. We have a hydrogen, deuterium here. We have a OH and a hydrogen at this center. Now I have SOCl2, and I have written along with SOCl2, let's suppose pyridine. And you need to form the final product. Do it fast. You have CS3 present here, a C2H5 present here. Let's suppose I have a OH and a H at this center, and we have a deuterium and a hydrogen at this center. And I have simply written as SOCl2 and asked you to draw the Q product. You need not to do anything, just to see what has been written with the SOCl2. If we have pyridine, then you need to remember, yes, we have to form the inversion product. Now, in order to form the inversion what you will be doing is, let's suppose your OH is attached on the right side. It means your Cl will be attached at the opposite side. You just need to form the inversion product. Examiner can give you multiple options also, just changing the position of the groups, that we will able to identify in the exam. Do take care of that point. So, in order to form the inversion product, okay, what I will be doing is, the Cl will be attached at the opposite center of the OH. Hydrogen automatically comes at the position of OH, and these centers are going to remain the same way. So this is your final product, and which will be of course of inversion. In the second case, we have to form a retention product. Nothing has been given, so we will directly replace OH with Cl, keeping all the positions of the substituent same. Some more options can be framed on the basis of this, that we know and that we can handle in the exam. No problem over that. So these are the two more type of questions which can be asked on the basis of SNI mechanism. Got this? Of course. So your this SNI is very small mechanism. This we have covered. Now we have to start a very important mechanism, that is SNNGP. Every year, or I can say at every alternate paper of CSIR NET, NGP mechanism is asked in your exam. Be it IIT JAM, be it GATE exam, NGP is very important for any exam if reaction mechanism topic is present in the syllabus. Okay. SOCl2 PY is a one name reaction. I didn't recall. Sir, is there any kind of name reaction? SOCl2 along with pyridine. Hmm, which type of name reaction? I am also not clicking right time this time. Which type of name reaction? I think so. It might be, but not remembering anything like this. If you remember, then please do tell me in the comments. Okay, Diksha. So let's start a new mechanism, that is going to be SNNGP. First of all, tell me what this NGP means. Yes, this is called as neighboring group, neighboring group participation. It means this time your neighboring group, the substrate which has a living group, will have a neighboring group, and this is going to participate this time. How the substrate is going to look like of an NGP reaction and what will be the basic reaction going on, first of all we will get through that, then we will be getting into the complicated parts of the NGP. Okay, see what happens. Always you have a substrate with a living group. Let's suppose the position at which the living group is attached is called as alpha position. Then the next position will be called as beta position. And at this beta position you are going to have a group which will have either a lone pair or either a double bond or a alkene center, I can say. This lone pair or double bond attacks at the carbon center and the living group will be eliminated. So this group which has lone pair or a certain kind of alkene, then it is eligible to participate in the reaction. So before the nucleophile attacks at the living group center, our group attacks at the alpha center and removes the living group. And of course, this type of attack is going to be a type of SN2 attack, or we can say an intramolecular SN2 attack is taking place. Yes, very good, Camp Pacific. This type of behavior where the neighboring group is participating and eliminating the living group is also called as n-chimeric assistance. N-chimeric assistance. Uh, Set exam. I think Maharashtra set exam has asked one time ki what does this n-chimeric assistance means. This behavior of a neighboring group of behaving or participating in the reaction is called as n-chimeric assistance. Okay. So now, once this living group has been eliminated, we have a cyclic intermediate. Since this group has donated something, so we'll have a positive charge, And now your nucleophile comes and attacks and opens the ring. You have two centers A and B. Attack can take place either at either one of them. Let's suppose if we attack at the A center, the product is going to look like a nucleophile attached here and the group attached here. And if we attack at the B center, the product is going to look like a nucleophile at B center and group at A center. Now, if we compare this starting material with our product, what we see is the nucleophile is simply attached at the same position as that of a living group. And we see that the product formed is of retention. So in NGP mechanism also we always form a product of retention. Why? Because here also 2-time SN2 reaction is taking place if you notice. The first SN2 was when the neighboring group participated and the second SN2 was when the nucleophile opens the cyclic intermediate. So here also we will form a final product of course, of retention. And the two products which we have drawn here are identical, same homomers. What do you want to call? You are free to call them. Same identical homomers. Got this? This is a some basic portion which is happening in an NGP reaction. Now, in order for this group to participate, it is very important. In order to make this enchimeric assistance happen, it is very important that both the neighboring group and the living group should be anti to each other. If they are not anti, then the neighboring group cannot attack into the sigma star orbital and it cannot eliminate the living group. So this is what some uh, basic reaction which an NGP reaction goes through. Now, it becomes very important in the examination hall to identify that yes, this particular question is of NGP so that you can apply your concept. So, what we have done is we have distributed this neighboring group participation in few cases so that if the question comes in your exam, it clicks in a second that yes, this question is from that particular case and you will be able to solve the question. Okay. So if you have written this, then we will move ahead and we will distribute this NGP into few cases. Yes, 2 times here also SN2 is taking place. So the final product is of a retention. Let's move ahead and see what are the cases in an NGP reaction. If we are talking about neighboring group participation, one of the necessary condition is yes, the living group and the neighboring group. NG stands for neighboring group and the LG stands for living group. They both must be anti to each other. This is the first and foremost condition for NGP to happen. They should be anti to each other. This is very important. So this will be our first condition. Then afterwards we will be dividing this NGP into further cases. The first case arises when we have, let's suppose, or we can draw in this way also. Let's suppose we have a living group as of OTS and the neighboring group which is present is an OAC group. This is the case number 1 from where lots of question has been asked in your exam and will be asked further also. So case number 1 where you have OAC group as a neighboring group and OTS group as a living group. A lot of question comes from this case in a form of 6-membered ring where you have an, let's suppose, OAC group attached here and you have a OTS group attached here. Important condition is they both should be anti to each other. Okay. Chem timing things that I gave jam this year cause some silly mistakes. My exam did not go well, but there is possibility of NIT. What should I do? Should I prepare for CUT or prepare for NET? You should prepare for CUET exam, and yes, it's something positive has happened that yes, an option to NIT is open. So first of all, go for CUET exam. NET exam, of course, you can give that into your MSCs also. No, You can give in your first semester, second semester, third semester, fourth semester. You have 4 semesters left in MSc to give NET exam. So don't bother about that. First of all, prepare for CUET and get an good college. Then you can, when you have two things in your hand, you get an option to choose whether to go into a good central university or whether to go into a good NIT. If you get the option to choose, then it will be better. Okay, cam time. See, so the case number 2 is going to be where you are having very famous case number 2, where you have OTS as a living group and a phenyl group will be present here, which is having a pi bond which will behave as a neighboring group, or the phenyl ring enchimeric assistance is going to take place. So this is going to be your case number 2. Case number 1 was when OAC group was behaving as a neighboring group. Case number 2 when a phenyl ring is behaving as a neighboring group. Okay. Sir, from which book, which chapter can I practice and more questions of NGP reaction mechanism? Okay. Sir, I left my lectureship with 5 marks. What should my next strategy for June 2024 exam? So you are very close to achieve, or you can very easily get through the net. See, you must have done some sort of silly mistakes. So your preparation is good right now. What you need to do is now add a few more topics, extra topics which you have left in the previous attempt. Let's suppose solid state I'm just taking an example. Let's suppose solid state is a topic which you left. Now you have a time, so you can cover that also. Try to expand your syllabus a little bit more and try to practice more and more questions. Go through the practicing questions from reference book also, from any practice set also, from the previous year also, so that you can easily solve the question and minimize your silly mistakes. Okay, you will get through the net. It is not that difficult for you. It will be not that difficult for you if you go through this, if you practice so much questions. Yes, sir, I have left some major topics of physical. So now it's time to cover that topics. Okay. Pi is asking for book. See, Pi, you can refer to Claydon book. Once you have covered this concept from here, what I am explaining here, then you will be very easily able to solve all the previous year questions. So first of all, solve the previous year questions. And then if you think you need to practice more questions, you can go through Claydon. You can solve each and every question of Claydon also. Okay. And in text and your chapter questions, or the, I can say, the exercise questions which are given at the end of the chapter of Claydon, you will not find into the new Claydon, but when you will look at the old version of the Claydon, you will definitely find it there. So moving ahead to case number 3. In case number 3, what we get is, this was our case 2. Now we will move to case number 3. Here we have a OTS as a living group. Let's suppose now the bromine is going to behave as a neighboring group. But bromine is also a living group, sir. It can behave as a living group. Yes, it can behave, but it depends along what is present along with the Br. If let's suppose you have an OAC group, then the Br is going to behave as a living group. And if you have, let's suppose, OTS as a living group, then of course the books generally do not use OTS, so we will not be using OTS. What books uses, they generally give you OH and an acidic condition so that this OH is protonated. So this is going to behave as a living group, that is a water molecule will be eliminating here. So the Br is going to behave as a neighboring group in order to eliminate the water molecule. So this case number 3 also becomes important. Moving ahead, case number 4, we have a NOR-borane systems. Case number 4, where we study and deal with some NOR-borane systems. Let's suppose you have OTS here and a H here and a double bond present here. Then how this double bond participate, how the intermediate forms a non-classical carbocation, how it forms a 3-center 2-electron system. These all things we will be covering when we will be starting case number 4. And then a separate case number 5, what is left in the NGP will be covered here. And of course, last year also in December net, the question was asked from the case 5 also, which we have named it as miscellaneous. This miscellaneous portion covers Baldwin rule 2. It means, in reaction mechanism chapter, there is one subtopic called as Baldwin rule, which is very important, which governs how the cyclization of the rings takes place. Baldwin explained on the basis of entropy, enthalpy factors, how the rate of cyclization is governed. Over this, I have made a separate lecture also of 6 lectures on Baldwin rule. I will suggest you, if you want to know the Baldwin rule in depth, then you can go through that lecture series also. So for now, the case number 5 will be your miscellaneous case, which will be further segregated into few topics. I am writing here because it was not visible. So case number 5 is going to be of miscellaneous. Okay. Now, first of all, we will be starting from case number 1. Once we have covered this, then we will move on case 2, case 3 and so on. Okay. For NGP, I recommend you to go to the reaction mechanism playlist explained by Hitesh. Yes, sir, you can go through that also. Sir, please take reference book exercise question more and more for this topic. Okay, Pai, I will take that questions. When I will be starting the practice question series from Wednesday, I will add some reference book question also, and I will show you how previous year questions are asked from this topic. Okay. So now we are going to start case number 1. So we'll be writing here as case 1. In case 1, what we are going to meet is a group which is OTS and a group present here which is a OAC. Now what happens whenever an OAC group is responsible for removing a OTS group, such type of reactions are called as acetylysis reaction. Of course, your nucleophile will be also present here. Such type of reactions are called as acetylysis reaction, where an OTS bond is breaked by an OAC is called as acetylysis reaction. Once this happens, you will be forming a cyclic intermediate, an oxygen, a double bond and a 5-membered cyclic intermediate. Then of course your nucleophile is going to come attack at one of the center and the ring is going to open. This is a very elementary form of the reaction which I am explaining you. We will go into the depth with some stereochemistry also. So this is how your product is going to look. You are having an OAC group in the place of OTS. It means a retention product has been also formed. But the question in exam is going to ask you this way. They will be giving you a 6-membered ring. Let's suppose we have a OAC attached here and a OTS, which is our living group, is attached at adjacent center with a stereo below the plane. Of course, we have ACOH where we need to form the P product, and one more question where we have OAC above the plane and OTS also above the plane. And again we have ACOH as a nucleophile and a Q product need to be formed. So I am giving you this question homework. We will be starting tomorrow's lecture from the same topic and I will go into depth of this question, how we can understand NGP and the complete with chair form also and with the normal situation also. Of course, we need to compare the rates also. Let's suppose this goes via K1 rate, this goes via K2 rate. I think more than 5 to 6 times this question has been asked if I include GATE, NET and SET exam together. And of course in JAM also, particular this question has been asked more than twice, thrice and I can say more than 4 times. Okay, so this particular question becomes very important. So we will continue tomorrow lecture from here only so that once this is covered, I will be starting case number 2 and so on. In this week, I will try to finish your NGP and then we will go on the practice question session. I strongly recommend you to attend the practice session question. If you understand the whole concept, then it's very important to replicate in the question part also. Okay. So let us keep it this much only. Thank you so much everyone for joining live and I hope I have conveyed some important points to you and you have learned something new in this lecture. Thank you so much. Take care. Bye bye and happy learning.